Hey, welcome to our fourth and final session for the review of the preliminaries chapter. Today we're going to talk about trig functions, something that's probably near and dear to your hearts. Basically, trig functions, which you should have had last year, can be defined as the ratios of two sides of a right triangle. The three main ones, sine of x, cosine of x, and tangent of x, you can see for example, sine of x is the opposite side of a right triangle divided by the hypotenuse. Opposite being the side, opposite the angle you're talking about. There are three reciprocals of the basic three trig functions, and the reciprocal of sine, for example, is cosecant, and we would define that as the hypotenuse over the opposite side. Basic trig values. This is something that you need to know. You cannot have a cheat sheet. You need to know them. Later on, we will show you how to come up with some of these values from what's called a reference triangle. Trig functions, you can describe the angle two different ways. You can describe it or measure it in degrees, or you can measure it in radians, okay? I would tell you that when you're using your calculator to solve equations, make sure that your calculator is in radian mode. There are 360 degrees in a circle as there are 2 pi radians in the same circle. Converting between either is simplified by using a proportion. Let's say we want to convert 30 degrees to radians. What I do is I say, okay, I've got the ratio of 30 is to 360 as n is to 2 pi. Solve that proportion for n, and you get n equals pi over 6. I know that pi is 180 degrees, and 180 divided by 6 would be 30. Reference triangles. Useful to determine basic trig values. On the left, you see a triangle. It's an isosceles right triangle, meaning it's a right angle with two congruent sides. Therefore, the angles are 45, 45, and 90. If I just arbitrarily pick two values for the congruent sides, it doesn't matter what, but let's say I call them each 1, then the hypotenuse would be the square root of 2. If I want the sine of 45, I would take the opposite side, 1, over the hypotenuse, which is square root of 2. I get 1 over square root of 2, which when we rationalize, it becomes square root of 2 over 2. And that would be the value for the sine of 45. Notice you get the same value if you take adjacent over hypotenuse, which would be cosine. So you know that sine and cosine are equal at 45 degrees. You also know that the tangent of 45 has to be 1. Why? Because tangent is sine over cosine, and sine equals cosine in this case. When you divide two things that are equal, you get 1. Or, using the definition of tangent, opposite over adjacent, you can see it's 1 over 1. In the triangle on the right, I've chosen this as a 30, 60, 90 triangle. If you look at the 30-degree angle, let's say I make the opposite side 1, okay, and I make the hypotenuse 2. Why am I doing that? Because I know that the sine of 30 degrees is 1/2. Okay, based on that, I can now come up with the values for other trig functions. For example, cosine adjacent over hypotenuse would be square root of 3 over 2. Okay, so the cosine of 30 is the square root of 3 over 2. The sine of 60, which is the complement of 30, would also be the square root of 3 over 2. Remember that the sine of an angle theta is equal to the cosine of 90 minus theta. We say that sine and cosine are complementary. Trig inverses. Inverse of trig functions are denoted one of two ways, either by sine -1 of x or something called arc sine of x. In each case, they are asking for what angle has a sine of whatever's in parentheses. For example, sine -1 of 0.5 is asking what angle has a sine of 0.5. The answer would be 30 degrees, or in radians, pi over 6. Keep in mind that this angle could occur in the first quadrant of a unit circle or the second quadrant, because sine is positive in both those quadrants. So there's really two answers there. Period, domain, and range, or PDR. Trig functions repeat themselves. That means that they're periodic. How long does it take the function to repeat itself is called the period. The period of sine and cosine is 2 pi, while the period of tangent is pi. The domain for sine and cosine is technically it's negative infinity to infinity, but usually you'll see it in most problems either as negative 2 pi to 2 pi or even 0 to 2 pi. The range, however, for just sine of x or cosine of x is always negative 1 to 1. Sample problems. All right, let's say we have y equals sine of x divided by 2. So let's sketch the graph and find its period. Okay. When I sketch the graph, I get something that looks like this curve that you see in front of you. Okay. To find the period is very simple. Set x over 2 equal to 2 pi, because that's the period of a normal sine function, to find out what x has to be. If you solve for x, you get x equals 4 pi. Okay? So if x is 4 pi, the curve is essentially stretched out. In other words, it takes a longer time for sine to achieve all the values in its range. If it was sine of 2x, the curve would be scrunched together and it would achieve all the values in half the period. Okay, so the period would just be pi for the sine of 2x. Another one. Evaluate secant of arctan of 2x. Okay, this one's a little trickier because what they're asking you to do is they're saying, hey, arctan of 2x, tell me what angle has a tangent of 2x, and then give me the secant of that angle. First thing, set up a reference triangle. Okay, what do you know? Well, I know there's some angle that has a tangent of 2x. That must mean that the ratio of the opposite over the adjacent side is 2x, or 2x over 1. So if you look at the drawing, you see I have the opposite side is 2x and the adjacent side is 1. Using Pythagorean theorem, I can figure out what the hypotenuse is. Once I know the hypotenuse, I figure out the ratio for secant, which happens to be hypotenuse over adjacent. So therefore, I have square root of 4x squared plus 1 over 1, which really simplifies to 4x squared plus 1. Okay? This concludes our last lesson on trig functions, and probably next class you'll take a short quiz on Edmodo. I will give you a practice test on the preliminaries, and then we will have a probably a 100-point exam on the preliminary chapters. Okay? Thanks for listening. See you later. Bye.